Hello, welcome. Yeah, so I'm I don't really know where this video will go here, or I mean stream here, but I'm just gonna start and see where we end up. I have now today I've got like a lot of time, so I could spend basically my entire day here streaming if I want. So there's no rush like that. But yeah, anyway, so I'm developing my Metroidvania game and also tools to help make the game as well. And also in the process learning the Zig programming language, and hope to show like what I've learned, and yeah, spread knowledge about the language, and so yeah. But let's see. We have this giant list of to-do things in the editor. Let's see, where did we left off last time? I forgot. Yeah, so okay, last time I'm gonna show you what I did. So yeah, let's get this started. Okay, there we go. So what we did last time was, well, one thing is that the let's say I create a new scene file, and then every scene file needs to have one tile map assigned to it, and it's this one, this as an input here. So what I do is, what I did last stream was implement this plus button. If you don't have anything here, you can press the plus button, and then you will automatically go into the create new asset for this type of asset. So you can create a new asset, and then boom, once you've created it, if you go back to the file that you just were in, you can see here that we automatically set this to the new asset. So that's a way quicker way to, if you want to create a new scene, it's gonna go a lot quicker. Well, it's basically just me using this tool, but it's good for me. So then I can start, you know, drawing this out here, and go back here, and you can see it's already updated here. So yeah, that's a really nice thing for productivity here. Okay, the other thing that we did was, so I did the scene map. So if I press M here, I go into the scene map, and this basically shows the all connected scenes basically. And it basically connects them using the entrances and exit entities. So this one, for example, has an entrance and exit over here, and this one has an entrance and exit over here, and they're both connected to each other. So the map auto generates, it knows where to put them in this map thing, and then I can also like click to go to that portion. So it's very easy to switch scene depending on where you want to go. So, and it shows like the whole thing. So yeah, a really nice way of navigating, and also looking at the entire map at the same time. And another thing is that you can see over here it looks a bit crowded, it looks a bit weird. That's because we've got a lot of overlap happening over here, and that is because this room, which has entities and exits, normally I have them like at the outermost boundary of the time map, and then usually you don't get overlaps. But here it's actually like in the middle of the thing, and if you have like the dimensions a bit wrong, then let's say this one, for example, is connected to here, to this one, which is connected to this one, and then you go up to this one. and then you go right to this one. But you can see they're sort of overlapping, and they shouldn't be overlapping that much. So it's also a nice tool to actually see if your tile maps are sort of logically sized and placed. So here, for example, if you go, the one that goes up is this room. So this room goes up to this room. And over here you got another thing, this one. Or this one, yeah. So this one, but this one actually overlaps over here. So that means that I can, I can basically, let's say, for example, I count this. I can count 1, 2, 3, 4, 5, 6. Okay, so if I just expand this scene here, and I have to go to, oh yeah, that's another thing we did also, was the, where is it? Well, I can just go here. The asset input, now you can right click and click open to actually go to that asset. So that's also a really nice convenience there. But anyway, so this one, if we expand this by, let's say 7, because I want to keep it, or maybe no. Yeah, I want to. No, let's just expand it by 6, so that will be 71. Whoops. Okay, yeah. For one, it's this that should change, and it's also like if you change it like this, it's gonna like erase the data. So that's also not that great. But I can do this and then set it to this. So now it's expanded by, I believe, like 6 times here. Yeah. And what we can do now is we can do simply choose you and move you all the way over there. So now we should have 6. 1, 2, 3, 4, 5, 6. Yeah. There we go. So now we've done that. So let's save that and go back to the scene and back to the map. All right, the map is actually not updated now. I think it's updated when I save the scene though. Yeah. So it's updated when I save the scene. Also, this boundary looks a bit weird. Oh, is the positions not updated, or? Yeah, it seems like the positions are not updated, so that has to be. I'm gonna write that down as a bug. And also update scene map when tile map is saved. When scene map is updated, the cell position was wrong, or something like that. I don't know. Because it looks like maybe the size actually did change, but no, it didn't. The size didn't change. Yeah. The cell size didn't change. Okay. But yeah, so that's a lot of, like, you know, quality of life stuff I've added in last, and that's a nice thing to have. Now you can see over here as well, we've got these two. Let me actually fix this maybe first. So I wrote those things down here. So first off, we can do this. So update scene when scene map when tile map is saved. So we do have an update when the scene is saved. So if we go to the scene and we look at the save function, or this part where we do the saving, we do this, and yeah, so we are updating the scene map here. Now let's go to, where are we? The time map, yeah. And let's search for save. So here we got a separate function here. Wait, remove, why is that like twice there? Okay, but anyway, I'm gonna have that here as well. All right. So now it should be generated when we save the time map as well. And I think that's it. There's nothing else that's gonna affect the scene map. So yeah, that should be done now. I'm not gonna test it right now because this part is also adjacent here. So I'm gonna test once I've fixed this as well. So when scene map is updated, the cell size didn't change. Actually, we could test it to see if it works the same. Well, I mean, it should, because we're calling the same function. So let's go to the map, and now we can see here the boundary is now correct. So if you go over here to this one, well, it's probably easier to check to do this one. Although it looks like we need to expand it, move it by 1, 2. Oh, the position doesn't really line up properly here. Let's do like, wait, why is it like all the way over there? That looks weird. Okay, but let's move it across a little bit more. Oh, because these things was okay. Need to move this out. Let's do 1, 2, 3, 4, 5, 6, 7. There we go. Okay, so this is a test as well. We save it, we open the map, and it didn't really update the position here. So that's what the issue is. So yeah, cell size and position did not change. So let's fix that. Alright, so here is the scene map file where we have the logic for doing that. So this function is the one that's getting called when we try to like update the map to the latest stuff. So first we find the starting scene, which is basically you find a scene that has connections to other scenes. So that it has an entrance and an exit, and there's another scene that also has entrance and exit, but they are both connected with each other. And then it starts to do a recursive traverse through all the scenes, because a scene can have like multiple. It's basically like a graph structure. It can have multiple connections to other scenes. And so this comment is actually outdated here. Let's see. Yeah, so what the problem is that we're facing is that the positions and the stuff is not updated. So maybe I think the problem is this part, because yeah, I think the problem is that we skip everything, because this is not, when we generate a new map, this hash map is not actually deinitialized. It's not emptied of the previous result. I think that's a guess. Oops. Yeah, it seems like it. So I think the first thing that we want to do is we want to do, let's see, are we also like doing, yeah, when we render the map we do a new thing there. So process scene if it's a starting cell. So actually yeah, in here we could have, I was thinking of having it outside instead, but we could say if seen to be no, if load cell options is equal to the starting cell, then we will basically want to deinitialize this. And we set it to an empty. So we restart, because this is only going to happen for the first cell. Okay. Let's try that. Alright, let's check this out. Okay, now you can see it's like properly sort of placed here. It's a little bit off because it depends on the entrance and exit position in the thing. So you can see here it's like it's a little bit off, but yeah. As well as, you know, there's a little bit of gap here because it's not that it's like an aesthetic choice. It's more like that's how the entrance and exit actually connects up here. Via their like positions and stuff, so it's not actually, and I tried to keep it the same for everything, like having 7 pixels off the screen, off the level boundary, and that's why it looks like it's the same everywhere, except this one looks a little bit shorter actually than those. But that's also something that I've thought about, like automating the entrance and exits somehow. I'm not sure exactly how, like maybe it's gonna be the boundaries of yeah, I'm not sure. Maybe you just define that there's a line where this is an entrance or an exit, and it should really be the same, maybe same entity. Well, you could have entrances that is also not exits, I guess. But if it's just a line, okay, I'm just speculating it, but if you can just have a line, then you can say that, okay, you can programmatically then say that, okay, we have a line here, but then the actual boundary is like outside of the, you can have a line and like a direction maybe, so that the game will know, okay, it's gonna be 7 pixels off over here, so you don't have to like have a 7 pixel, like manually do it every time. But that's something that we might do for the future as well. But anyway, this seems to look good now. So I'm gonna jump to this part where this black part shows like this is meant to be like the previous level. Let's actually remove that for now. Maybe we have like just a line. Oops. Let's just have a line so we denote that this is like the boundary space for this part. And we save that. Now we go back and we can see it's been updated. You can see it's been updated. However, we don't really know if the, and so you can also see here that we probably want to update here as well. See, it's a lot easier now to actually do this. So let's see where this ends up in the map. So we probably need, this actually goes pretty spot on here. So let's just draw this in a little bit and see, okay. So it's gonna be like this, right? Yeah. Let's draw until we get to the end there. I mean, this could really be one. I wonder if that's behind the black or not. It's probably not, because this is supposed to be. Okay, 1, 2, 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. No, it's probably behind the blacks. But then again, it's like not perfectly overlapped either, so whatever, you know. Yeah, so this actually, if you go over here and you jump up, then you get down, basically go down like this part. Yeah. So now it's you can see that it's better. We didn't need to change the size or anything for this. However, maybe no, this doesn't really make sense. Like, this upgrade room is way too big. The boss room goes. It's pretty good. I mean, if we change the upgrade rooms to be like this instead, maybe that will work. The question is, like, does it really matter? I'm not sure, but at least you can sort of now work your way through this a lot easier to see how it all comes together. But really, these two is like, okay, should they be two different maps? I'm not sure, but now they are, and yeah. And this one, does it matter if it like overlaps a little bit here? Like, would the player even know about this, think about this? Like, on the actual map, how would that look? Like, it depends on if the map shows the exact sort of locations of everything, I guess, maybe. If it's like an actual one-to-one map, then I guess it would matter. But let's actually do this. So let's see. Well, for one, this is way too tall then. So we need to basically, I'm gonna try and draw some over there. Let's do like a 3 wide and we'll see. Okay. So it's gonna be like this. We'll just remove this. Okay. Now let's change the size of this to like, I don't know, 9. Okay, that was perfect, I think, maybe. Okay, let's save and we'll see. What if we do this? And then we go to the scene of this. And we need to move these up. Okay, you can see we fixed the issue that they now this is like it's saved properly and the position and stuff is updated, and now it fits here with the actual map. Cool. Now let's fix this one. So we'll open up the time map. We will change the width to, I don't know, 35 maybe. Whoops. I have to fix that as well. I think that while you're editing the size, it should really not like update until you've like sort of committed the thing. Is that too large? I think we only want like, well, it's gonna be here at this part basically. So something like this. But it shrinks from this side, so it's kind of hard to. Okay, so it's gonna be this. Now I wish I had like grid coordinates so I can measure how far this is. Actually, I want to put that in the to-do here. Time map or the to-do. Okay. So I'm not gonna like count this, but let's see. 35 should probably be. Well, maybe that's actually not too large. Let's then move this over here. Okay, that's pretty good actually. Except there's a problem. Well, actually, it is not a problem. I was thinking like, hello Pollock, welcome. How's it going? I was thinking like the boss room was gonna have an opening here, but I can just as well like move it up here. When you defeat the boss, it opens up here, and then you can go into back here and go back quicker. Good. What are you working on? I'm working on a Metroidvania game, and also the editor to make the game, basically. And I'm using Zig and Raylib and Imgui for the editor. So right now I'm working on the I'm just testing out this map feature that I built last time. So you can like all the scenes here, like each box here is its own scene, and I kind of stitch them together and build this map automatically, so you can see how everything fits together. And so we found some stuff here that like overlapped. Swedish accent, yes, that is correct. Are you Swedish as well, or? Yeah, I'm building my own engine. I'm using Raylib for rendering and sound and stuff. And also a library called Zig ECS for storing like components and entities as well. Yep. Let's see. So let's add like, I don't know, 4 maybe to this. Oh, but now this one is, oh, they are moved over here. Okay, so now it looks a lot better here with a bit of like overlap. Well, it's not, there's no major overlap now. How long have we been developing the engine? So I started at, I think it was like November or something like that last year. So yeah, it's been a while. And I'm trying to get more content in the game because I really want to get progress on that. So I basically mapped out this first sort of area where it's basically I have a vision like in the finished game is going to be larger and have better like integration with other abilities that you're gonna find, but it's gonna be a starting place to actually like continue building out the game. But yeah, I'm basically, I do have a day job and in web development, so, and a family as well, so I don't have a lot of time actually working on it. So, but slow and steady wins the race, as they say. How is the game dev scene in Zig in general? Are there any widely adopted engines? Well, for one, Zig isn't a super popular language. It's starting to gain a little bit of traction, I think. But it's starting to get more popular, and it's also not super like mature yet. So there's still like breaking changes happening if you wanna try it out, and the next version is probably gonna have like breaking changes and stuff. Well, that's happened like in the last version at least. But what was I gonna say? So there are a couple of engines. I believe one is called Mach, like MACH engine, which is being worked on, and looks like one of like the nicest ones there, which seems like it includes a lot of stuff, and it can handle like 3D and yeah, a lot of good support there. Then I think let's see. Well, there are like wrappers around like SDL3, SDL2, and yeah, so some low level, so to speak, stuff as well, like that. Actually, I want to try something here. I do have a like a Twitch chat integration here. Let's see if it works. It doesn't show the thing. There we go. It doesn't show the previous messages. It shows the ones that. Okay, so my idea is so if I. Yeah, I can show it, and because it's like a floating window, so it shows over the thing. So if I want to see what's behind, I can just hide it. Okay. So we fixed the bug. This one, yeah. So what do we want to do now is the question. Do we want to work on the editor more? No. Well, it just spells it out. Because I think it's because of the terminal that I'm using. Also this chat window is you can see up here is Bork. It's like a Zig project that someone made for I don't know who made it, but someone made a Zig Twitch chat thing here. So I'm using the it's basically a what you call it, a terminal program. So I'm basically just opening a window in NeoVim and showing that, like opening a terminal and running the thing in there. But the program that I'm using, the terminal sort of program that shows the thing to Windows here, is WesTerm, and that doesn't have support for like the protocol that Bork uses here. So I think that's why it can't show the emotes. I'm not sure, but I think that's why anyway. Okay, but let's see. What do we want to do now here? Well, I'm not sure. I'm just looking through here a little bit. I wonder how it does, like, just normal, like, these things. Yeah, that's just a smiley face. So are you game dev, or do you are you into programming, or? see, account origin. Oh yeah, that's the animation stuff. Sprite sheet and tile sheet. We don't really need that right now. Right. Oh, so we're in the same boat then. Cool. Are you back end or front end or full stack? Let's see. Time of show grid. Yeah. Probably want to update this a little bit because this is what I'm gonna work with a lot. Grid is not super helpful right now, I don't think. Bucket tool, I guess, but I have to look up like the algorithm for that because that seems like a hard problem to me. Setting to disable enable all expand when drawing outside of boundary. Very much full stack, doing a lot of local first stuff recently, so more front end. Oh, okay. Local first. Do you mean like SPA or what? Or like I'm not sure what you mean by local first. Also, what do you like Metroidvanias, or what kind of games would you want to make? Yeah, I think this one would be nice to have. The problem with this is that the entities will not move the way same like so if we go in here, I can see here are the entities, and if I change the size of the time map, so if I increase, let's say, the Y here by 1, it just goes down here. So it's not, so the entities stay in the same place. I guess it makes sense. How would it know how to move them? Because we don't really know how to move the tile maps either. So maybe it's like I don't know. Depends on. Yeah, more like SPA, PWAs with all data storage and logic in the client. Oh, okay. Cool. It's interesting, that part, because it's like I think web development has gone like back and forth now a couple of times with that sort of paradigm, or whatever you want to call it, architecture. I think I mean I think because there's been I've seen like a movement that goes like, oh, we should move away from SPAs and have more you know, server side rendering and stuff, but then it's like, but it does make sense to put some stuff on the front end as well. It does make sense to have like you fetch some data if you only need the data, and then the front end knows how to display it. Yeah, I don't know. Is it that's a whole discussion in itself. That's a lot of things to say about that. I haven't played that much Metroidvania actually, but I guess more towards 3D and multiplayer stuff. Oh, okay. No specific genre in mind. Yeah. My problem has been like I've had so many ideas of games that I wanted to play and make, but it's like, yeah, it's I never actually sat down and actually put a lot of effort into making, or I have started, but a lot of projects, but then I never really continued with any of them, because you get stuck and you don't really. The thing is, then you get like interested in another project and you start on that, and you know, but doing it like that, also you get to learn a lot as well, like how to stop, because you get like further each time. Front end scene is funny, yeah. All the assets, yeah, all I've made everything like yeah, everything myself, but I'm not sure if this is gonna be like the I'm pretty sure this is not gonna be like the final graphic stuff either, so it's like or even, you know, it's not gonna be the final version in any way. Well, in some ways, I maybe like the basic map structure, but and some of the elements, but I'm pretty sure that this is gonna get iterated over many times, and then like we're gonna add, or well, I'm solo, so I'm gonna add. So if we look at the map here, so now it's nice because I can show the map. So this part is like the first sort of, what you could say, like area where you face enemies and then you go and fight the boss, basically. So for one, I think it's like too small right now, but I've made it so that it's small because I wanted to have like a basic structure that has all the sort of important elements. Like you have a sort of a winding way up to the end area where you find the upgrade, and then once you find the upgrade, you can access stuff on the way back to the boss here, so go fight the boss. Once you fight the boss, then you can go backtrack a little bit, but then you have more stuff to discover down here. So because you have access to this upgrade now, the upgrade allows you to go down here and then down here and up here. So that's kind of the idea. Like I want the important elements are that you're gonna get an upgrade, you're gonna defeat the boss, and you're also gonna see like, oh, this area I can't access this because I need some upgrade or whatever. And then on the way back, you actually get to access those areas on the way back. So that's like the important elements that I wanted to have. But then I think the area is like, it's too small if you want to have like a real game. I'm thinking like, I'm probably not gonna make it as large as like Hollow Knight. I'm not sure if you are aware of that game, but that game, like you could say that maybe the areas are like, I don't know, quadruple maybe the size of this for each sort of area. Also, probably the area is gonna be sort of intertwined. You're gonna be able to get to other areas from this area, and not just like go back to this is the village here, and maybe reach other areas from there. But yeah, I'm not sure. It's very open right now. I'm trying. It's sort of like growing very organically, this game. Everything from like the setting to like characters, what areas will be, what kind of bosses there will be, the gameplay. Yeah, everything is sort of in flux right now. So and I'm just adding a little bit here and there, and I'm probably gonna reiterate a lot of times on how the game actually plays. Maybe we'll see, but I can show you maybe like let's say we start here. I can enable the sound here as well. Does the sound work now? Yeah, I think the sound works, but my headphones are like broken or something, so they don't really register all the sounds. It sounds really weird in my headset, but I'm not sure if you hear anything. Does it sound weird to you? Other than it's like very bad sound effects because I've made it myself. And I'm not really a sound guy. Okay, yeah, so this is basically the game here. And so you don't really like right now. I did make this sort of combo system where you hold down a button. Now you're in combo mode, and you can do like inputs, and this sort of enables. I'm not sure if I'm gonna keep this mechanic, but it's like it's kind of nice because then you can I want to cast this spell instead of accessing like a shortcut or something. You have to input the correct thing, and so that becomes like maybe like a little mini game. I'm not sure if that's gonna be fun or not. I'm probably have to like implement more moves for that to work, and for me to test it properly to see if it's actually fun. But the only move that we have right now is this, and I died. Okay, so that's basically the game right now, and yeah, I need to add more enemies. I need to like figure out what to do next, basically, with the creative side of it. But I also want to like, you know, show Zig the programming language, and yeah, because it's a fairly new language, so I'm learning it as I go along as well. So that's also part of this project here. But yeah, I think I want to have this thing. Oops. So this is basically when you draw a tile map, when you draw the map or a level, you have like a set size, and what this will do is basically almost remove that size, that set size, and instead you can draw wherever you want. And then basically when you save, I guess it's gonna set the size to whatever maximum size is gonna be, depending on where you have drawn, if that makes sense. So I think I want to do that, because it's such a pain in the ass to have to set the size by changing an input all the time. So I think we'll do that actually. Hey, looks good. Thanks. Hopefully it will be a game that is fun to play. We'll see. I'm trying. I love Metroidvanias, and like Super Metroid, for instance. That's still like one of the best Metroidvanias. I mean, it's a Metroid game, but you know, it's sort of the same gameplay. Almost. Let's see. Where do I want to go? Here? No. Time map. So we want to add. So this is basically the UI state, you could say, of the tile map editor. And so what we want to do is we want to add a flag that says if this option is on or not. Which I'm gonna default it to true, because I probably want to test it out a lot, and I want to not have to switch it every time I want to test it. So this is going to be auto expand yeah, I guess auto expand. Is auto expand enabled? Okay. Yeah. And I mean, I guess we could add a checkbox for it. And we also, I want to add a convenience function here. Alright. Now we'll go to the layout stuff for tile map. Oops. And it's gonna be, well, it's gonna be somewhere here, maybe here. Wait, where? This isn't correct. What happened? Okay, I'm not sure what happened there. The LSP. So the LSP is a little bit, you know, it's also not really that mature. So sometimes it works against you, but yeah, it's fine. It's, you know, it's something that you have to live with when working with Zig here, at least for now. It works for the most part, but sometimes it has some weird stuff happening. So, tile map menu. What we wanna do? We wanna add maybe under size or below size. Let's see. So you just do checkbox, and this would be auto expand arguments. We have V, and this is a pointer to the thing that we want to change. Oh yeah, actually I have to change this a little bit. Let's do get auto expand, and this is a pointer to a bool, so we can actually change it. There we go. Wait, why did I go? Why did it go to the wrong place? Does this work? Yeah, that works. And this works now. Okay. So anyway, so here, auto expand, and the thing is gonna be time of document dot get auto thing there, and this returns a bool. And I think that's when it like changes the thing. So I'm just gonna set this to nothing. Oh, you have to like discard the value. All right, let's try this here. So yeah, now we have this auto expand thing, and yeah, the idea is that if I draw, like right now I can only draw in this. Wait, why can't I choose? Right, so I can only draw in this area here, but the auto expand will be so that you can draw basically anywhere, and it will automatically like expand to that area. So let's try and do that. So how would we want to do that? Oh man, it's really windy today. Not sure if you can hear the wind. Let's see. I think it's down here, like handle input. Yeah, handle brush. This is one place that's gonna get affected by this. Highlight hovered cell. This one. So yeah, here we can actually check this. So is auto expand enabled? Oh, we don't actually have the time of document here. Oh, because it's generic, right? So let's have a flag then, override out of bounds. We'll try it. If not override out of bounds, and right, now we have to wait. Why is the LSP not working now? So this one would be, yeah, so now we have to grab the setting here. Is auto expand enabled? And a document.get auto expand. And we want to override if it is enabled. And basically it should be the same for handle select. Here we're gonna do false. Okay. Let's see if it works. Yeah. It's kind of weird how when I go above here, this is like 0, 0. So when I go negative, it like inverts, or it sort of doesn't really work with the highlight stuff. It does work like everywhere else, so that's something that we need to fix. I'm just gonna write this down in the to-do. Highlighting cell is offset when in negative coordinates. So, are you still there, Pollock? Do you what kind of game, like what language would you like to use for game development, or do you want to use like Unity or something like that? Okay, so why did we go over here? Yeah, this is the thing. So let's see here. Now we're highlighting the thing. However, actually maybe we should fix it right off. Let's not worry about that. Start generic action. That is fine. Get mouse. Yeah, so this one, the safe part, I think this is like, it's should be in not out of bounds. And so if, so this is basically like if auto expand is enabled, we don't want to do the safe part. We want to get, we just want to get the mouse position. And I think then you don't need to, yeah, you don't need to pass in the thing there. Auto expand, yeah, so yeah. So now we're doing that. I wonder if this is an issue now. It does, I mean, I'm not getting a complaint, but I think because this part, this doesn't return a bool or a nullable or optional. It just returns a straight up vector. But this one is returning an optional. So then this expression should then produce a nullable vector, which it does. So that's actually interesting. It works out like that. So that's good. So, and then grid position is null, because that is one thing that, for example, Haskell would not allow. Well, I think it's good. I think this is like it's good because I don't have to, like, you know, convert this into a null or optional value myself, unless I have to. Is there like a null cast or something? I don't know. Well, anyway, brush on use. Yeah, so now in here, this is gonna be where, well, actually on use, this is kind of depending on stuff. Like here's where we are actually painting the stuff onto the tile map itself. And so we have to make sure that if we paint outside of the boundaries, we have to expand the tile map, and also possibly even move tiles. Like if, let's say, you paint outside, you paint like up here. Let's say you paint down here first off. So if you paint down here, then, well, now it crashes, but if you paint down there, it should just expand down, because the position is like up here, the size is here. So you paint down, then all the tiles are gonna stay in the same sort of position. It's gonna be fine. But if you paint over here, and then you have to change the size to, like, you add 3 to the size or whatever, and but then you also have to change the position because you're painting over here. So I have to change the position of all these tiles here to the right 3 times. It's either gonna be that, or you do it like once when, I mean, you could have like a temporary set of changes that yeah, you probably want to move everything just when we like paint outside. I wonder how much resources that's gonna use. Oh, probably not that much. I mean, it depends on the size of the tile map. But anyway, Let's see. I mean, there's probably a way better way to do it, but that's my first like naive thought. I think, yeah, this is gonna be so if we have a selected right, so this is like the random, this determines like what tile you're currently drawing. It's been a long time since I've been in this code, so I have to familiarize myself a little bit. Tile map, layer tile. All right. Oops. So what are we getting? Yeah, we're getting that. Yeah, by type. So here is the problem now. Since if we want to have auto expand, we can't just draw onto the tile directly. So before we do that, we have to handle the auto expansion, which is, yeah. So let's just do some top down here. So we're gonna grab the tile map. Handle auto expand. Yeah. So what do we need here? We need a tile map. Actually, let's just put in the timeout document. If this is enabled, or if it's not enabled, we return. But if it's enabled, we have to check is the grid position. So we need the grid position as well. We need to check if it's out of bounds. So where do we do that? Is the document is out of bounds? So we do have this. Yeah, so we can check that. We do need a timeout later, I think. So if this is not out of bounds, we also return. Okay, so that's like the initial checks there. Once we're here, we know that we have auto expand enabled and we're out of bounds, so we need to expand the time map. And how do we do that? So I think there's a couple of cases here. Either the coordinates are positive. So let's say if grid is more than, oh man, this is gonna be, let's just do this. And or equal. So if they are both positive, that means that we can just set the size to be ensuring that the area, how do you say it? Like, yeah, that this would be inside the new time map. So we need some sort of new, like, increase in size or new size. What would that be? So let's say we have the new size already. I'm just gonna do this for now. So let's say we have the set new size. Then we just do let's see, is it like grid size? I guess we just set the size. I guess we could implement a function in time map for that as well, because it's gonna affect not only the time map but also like all the layers. Yeah. Set size. Let's do like, I don't know, resize maybe? No, let's do set size, new size. Right. I guess we can assert that the new size is like not negative. Wait, it should be positive. Assert that it's positive. There we go. Do we have like anything else now? Okay, so we'll do that. And then yeah, so it's gonna be in here. So let's No, this is just gonna update the size. We're not gonna change the position of any tiles or anything. So this is just gonna update the size. So we'll do self.grid.size is equal to the new size. Yeah. And then we go through each layer. And we say, oh man, do we have to change the tiles as well? What's happening here? Oh, it's already a thing. Okay, now the question becomes, how do we deal with this? Is this a way more involved action than I thought it was? This is just an array list. Yeah. So we're just it's just a flat list. It's a one-dimensional list with all the things in it. So we basically have to change the size of that. Yeah, there's gonna be, okay, maybe I need to change the data structure here a little bit to make it more easily like modifiable. We could just have a list of lists. I think that's what I tried to do at first, but somehow it sort of didn't work properly. I think so, because now it's like if we wanna, let's say we wanna change the width, then sure, we just set the width to new width, but then I think all the tiles are gonna be jumbled up, because you have to sort of pad each row with some tiles for that to work properly. But if we have an array list of array lists, we don't really need it to be an array list, to be honest. But I mean, maybe if we have an array list of array list, then the if you want to add a, like, change the width, well, depending on which is the rows and columns, I'm thinking the first one would be the columns, and then these are the rows. So the first is like the x coordinate, and then it's the y coordinate change. Or is it supposed to be the other way around, maybe? It doesn't really matter, but I just think what makes sense in my head here, because I'm thinking like the inner, this makes more sense if this is like the row, so that each tile is like, I don't know, it doesn't really matter. But if we're thinking that this is the row and you want to change the width, then all you have to do, but you have to loop through all these. No, these becomes the, oh, this is the Y position in that case, and then this would be the X position. Yeah. So you loop through all the Ys, all the rows here, and then this will be the cells, not the columns. The cells. That's right. Yeah. So you just have to change the size of each of this list if you change the width, and that's it. And then if you change the height, you just have to change the size of this list. So I think that's how we want to do it. Yeah. But now we need to change a bunch of stuff. So we need to change how this is initialized. So instead of doing this shit, we want to see the first one is going to be the Y. And then these are appended n times. So we'll do array list tile empty, except this is probably not how we want to do it, because we want to do this, because we want to initialize one list per thing. One list per row here. Oops. Init capacity. Oh my god, I'm pressing the wrong key. There we go. So init capacity, this is gonna be, actually this is not n times, it's just append assumed capacity even. Yeah. So init capacity allocator with size 0. There we go. Yeah, so we're assigning basically the same size, except now it's in a 2-dimensional array instead of a 1-dimensional array. Alright. But this type is wrong. It needs to be this. And this is also wrong. It needs to be this. There we go. Wait, what am I doing? This one should be... No, this is fine. No, wait, it's not fine. This is wrong. We're initializing one array list with capacity size 1. We're looping through size 1 here. From 0 to size 1, like the height. We're appending a new array list into each row, which will be the cells of that row, which all have this. Okay, do we get back anything from it? No. Let's do row equals this. And then row append. Now this is append n times. Wait, append n times assume capacity, that's right. And the value is tile. Let's do dot empty. There we go. Okay, now I think we're back to where we were. So we have a row, list of rows. Each row has a list of cells. We're initializing with an empty tile for each cell. And then we add the item in here. So now we should have saved it into the row list area. Alright. what's happening here? Oh yeah, this is set tiles, that's right. So we're okay. So we're not done here. We have to also now handle everything else. Here we not only have to deinitialize tiles, we have to go into items, row, and deinitialize each row. Don't we have to deinitialize the time? No. I guess not. Okay. Now you can see here there's an error in the LSP. So this is an array list of tiles. Now what would the items be? Well, it's not a list of tiles. It's supposed to be a list of, well, it's supposed to be a slice of array list tiles and not a slice of tiles. So there's like, I think this is one of the reasons why I didn't choose to do it like this, but now I have to do it like this. So, or it's way better anyway. So this is not a tile, this is an array list of tiles. So we deallocate each array list there. Okay, now let's go through, and then we also deinitialize the initial row there as well. Okay, so now that means all the array lists there are initialized. For clone, we actually also have to do some stuff here. So clone for array list creates a copy, which means I think basically that it allocates a new list at a new location and then copies over all the data that's inside. But that's not enough. We need to clone the data inside as well. So we need to loop through while we're doing this. Oh, but this is not actually, this is row. And so row, yeah, we're cloning like this. And then actually we need to loop through row items. This is now the tile. Okay. Yeah. Okay, that's that. Stringify parse, same thing. Get tile by index. This doesn't make sense anymore. These are not even used, so I'm just gonna get rid of them. Wait, let's put it like this. Let's just remove those. Okay. Okay, let's continue here. Get tile by vector. So this one would be still, well, we have to change here. So we don't really need to calculate anything now. We can just say grid position 0 and then items grid position. Actually, it's the other way around. It's this. And we don't need get index. This is basically I mean, we could just do this return get time by vector, right? Name buffer doesn't matter. Okay, that's it. Right. So I think we actually, the layer, probably we wanna add a set size here as well. New size, vector. Let's assert that again. And let's see. We are going to do self. I mean, your self grid size equal to new size. Right. And then it's like the same, really the same thing here. Like if I guess there's like a couple of cases, like if the y has changed, if the y is less or larger. So let's start there. If we have to do it here. So if new size is larger than the current grid size height, then we will do tiles. We have to then append n times. We also have like ensure capacity. Oh yeah, we need allocators. The new capacity is going to be new size 1. Okay, so first we do that. Then we do append n times assume capacity, which is gonna be it's gonna be new size subtracted by the old size. That's the difference. Wait, no, that's n. And the value is array. I mean, it's just gonna be empty. Okay. Yeah, I really like that. You know, you can just say dot empty, and it works itself out. Okay, cool. All right. However, now we also need to like initialize this row here. So let's add init row. Yeah, and then we just do 4. So let's do new rows equals that. And we loop through that. And we say init row I. No, it's not going to be I. It's going to be like I plus. The size is going to be new size 0. Okay, so this is one of the cases that we have to go through. So we're checking, do we need to add more rows? If we do, then we just add that. We ensure the capacity to be the new size, which we can move that outside here, because we always want to do that. And we check here, do we need to add more rows? If so, then we do that. So this is the number of new rows that we need to add. We're adding them in here. Well, we're adding the space for them here. Or we fill. I'm correcting myself here a lot. We are filling the data here with empty things. We did make sure the space was available here, but here we're filling them with the data. And then we also fill the empty arrays now. That's the new arrays that we added. We're filling them with data here, or initializing them here. So, and that where we go, we have the length. We start at the length of the original array, which is at the end of the array, like the next item of the array of the last item. And then we add the new rows in from that. Okay, and then we add it every time. So that's that case. If it's like larger, then we will need to check else rows to remove is gonna be how many rows we had before minus the new size. So this, because now the new size is less or equal to this, so it's going to be 0 or, so this is going to be 0 or more rows to remove now, and it's presumably going to be removed at the end, I think. This is not really a case we're gonna have though. We're not gonna have this case actually right now, because it's like auto expanding, it's not auto shrinking the time map. So this is actually not a case we're gonna have, but I guess we can just assume that we're gonna remove the rows that are at the end if we want to do this. So let's see, this is gonna be well, first we want to handle deinitializing those rows. So we want to go from new size 1 to this. Right? And then we say this deinitialize. I'll just add that there so it doesn't complain anymore. Wait, what's happening here? Unused capture. Oh. Right. So actually we don't really need this, maybe. Is there a way to set the size here? Shrink or something? Resize, shrink and free. Ah, we can do shrink and free. Why would it invalidate the pointers if it only shrinks? Okay, I don't know. Maybe because it's trying to like optimize. Okay, anyway. Like put it in a place where it fits better or something like that. So shrink and free, that's probably a good thing we should do here. So new size 1. So we don't need to do this then, or yes we do. Shrink and free, it's like freeing. Yeah, it's reducing the allocated capacity. That's what it means. Yeah. So it's not freeing like anything except for itself and allocating it again or something like that. Yeah. Or remapping as we saw. Okay. So we don't really need to calculate the rows to remove here. Okay, so that's the Y. Now we need to, now when that's done, we need to check also the X. If the X, so if X is, also I forgot to say, this also handles the case where the new size is the same as the grid size. Because then you wouldn't get any iterations here. Because they both are the same size, so it's not gonna, it's like, yeah, it's not gonna do anything. And then this one would also quit, I think, because it's just checking. Oh, it's doing an assert. Yeah, because it has to be, it could be the same. If it's the same, wait, it does a remap anyway. So it doesn't check if it's the same. I guess maybe the remap could do it. No? Okay. Okay, let's just do this. Let's add a check here. If this is less than the size, then we want to do. Otherwise, we don't want to do anything. All right, now let's go into this case. So we have if the width is expanding. So if the width is of the new one is larger. So let's loop through all of our columns. So at this point we already have the new rows. The rows have already been like initialized. We're going through all of the rows here. So this is a row. And then we want to, for each row, we want to expand it. So we want to do ensure total capacity. I think you need allocator, and then you need the new size 0. So actually, we probably want to do this then. We want to do this for each thing. We're ensuring the total capacity. So we're going to do that for every row. And then checking my chat, went weird there. Okay, we're ensuring total capacity for each row. We want to check if it needs to expand. So here we want to do basically the same thing we're doing here. Append n times. News columns, I guess we can call it. All right. This one catch. There we go. Okay, so now we fill that with data that we need. So we already expanded basically the rows here, but here we're filling it with like valid data. And then I guess we're done with that one. Now we want to check the other way around. And what do we want to do here? We want to do shrink and free basically. This has to be like an error. This could be an error, right? No? So you're passing an allocator, but it might not be an error. That's very strange to me. But maybe it's like only working with already allocated space. I don't know. Anyway. Allocator and then the new size. And I think that's it. Actually. We don't really need to do anything else. And then we update our size descriptor here. Okay. And yeah. Now we're setting the size for both the important to not do this now because we are relying on that information in the function itself. Oops. Yeah. So we're not setting this until we're done with this whole thing. All right. Now that's one part of the puzzle. We need to reset. We need to set the size. So set size to the new size. So once we've done this, we'll probably get like a whole bunch of errors now. Yeah. Let's see. Oh yeah, because you should return and release the times. There we go. Oh, I need to. think no, that should be fine. Yeah, even the for loop needs a U size. Expected type. Okay. Also need to figure out what I'm gonna eat today. Maybe I'll just order something or I don't know. Expected type, array list. Oh. There we go. Member function expected one argument on the allocator or wait what? Probably allocator. Right. No. Intcast. Expected I32 found U size. Right, so let's do int cast. Okay, last error here. Set size, new size, allocator. And we also need allocator here. All right. Let's just add the context here so we can access the allocator and everything else if we want. There we go. Now we get rid of almost all things. Okay, here we go. This one also. Right, let's do U size, U size. Is this U size? No. Oh no. There we go. Okay, that's it. That's all the things. So now we actually do, well, we have to calculate the new size as well. But in theory, if we calculate the new size correctly, then it should actually set the size to that new size. So the new size should probably not be that hard. It's just gonna be the max. Well, if it's expanding, that is, it's gonna be the max of grid position and the current size. That's the new size. That's it. Okay. Then now we're oh yeah, so we are handling, this is only for the case where it expands in a into the positive area. So we can actually try this right now. This is the sort of the easy part. Now the hard part is then going to be expanding into the negative area. Oh, we get a crash already? Oh yeah, oh no. Okay, I think maybe this is the time where we implement, I mean, this is a new sort of feature, implementing versioning, upgrading from old version to new version. Because the time maps that are saved as flat arrays. So they need to be changed into two-dimensional arrays. How do we want to do this? Do we want to add maybe into the config here a version? And then we have like an interface, so we basically force all the documents to implement a get version. And then if we encounter an old version, we need to like automatically update it to the new version. Do we add it here? I mean, I guess we can try, because this is gonna, we can then use it. We need to store it in the persistent data. So all persistent data needs to have a version. So it's like the version of the loaded document, but then also the version of the code that we are currently running. So this would be the code version. How would that be? Just an integer, I guess, that we update. And then we bump it every time we change. Make a break, basically make a break and change that we cannot load the previous JSON file anymore. Or something like that. Like every time we update the thing. Yeah. I guess we could bump the version anyway, but the upgrade will be nothing. Okay, I'm gonna add this to the to-do here. Documents versions. So version upgrade system. Each document should have a version stored in the persistent data. Each document type should have a current version, and then each document type should have an upgrade So how would this work? Like we need to have some sort of upgrading system where if you load in an earlier upgrade, every time you load in a document, you're gonna compare. Well, actually, you can't load in the document. You have to load in the version first, and if it doesn't have a version, then it means like it's the old version. It's the version basically that is before this point in time. So let's say you have a version. Let's say we encounter. Let's say we read in the version first, and if that fails, that means it's an old version. So it's like pre this version. But if we can read in the version, we compare the version with the current version. If it's less than the current version, then we do an upgrade or an upgrade, I don't know. We do an upgrade of the document, so it's basically going to be converted to the latest version automatically. Maybe it's a pop-up that shows a new version is available. Would you like to upgrade? That would be maybe sometime in the future. But we need to have an upgrade implementation for each version number, for each version, for each adjacent version transition. I'm not sure if anyone would understand it. I'm just gonna do some examples. 1 to 2, 2 to 3, not 1 to 3 directly. In that case, it would be first 1 to 2 and then 2 to 3. So it's always like, the consecutive version upgrade, and all these up versions are gonna be, they are bumped because there's breaking changes, so it's not gonna be like an empty upgrade or something like that. So if you have version 1 loading in a version 1 document and you are currently on version 3, it's gonna first apply this to the data and then this to the data to be able to load it in. Now this is, I'm probably just gonna have that happen automatically when you load it in, and then if you decide to save, it's gonna update the actual file. But I'm not gonna update the file until you actually save it. So it's not gonna get updated automatically when you load it in here. So when you load in a document, first only load the version, or let's say when a document is loaded, it is also upgraded in memory if needed. if it is an old version. Okay. Okay, 1 second here. I'm just gonna order some food. What am I craving here? I don't know. Just gonna see what's available. Maybe no. Oof, maybe that. Yeah. Some Indian food today. But where's the... 20 minutes, 20-30 minutes. Okay, cool. Gonna turn on the sound here. Okay. Right, document version. Yeah, I think this should work. Probably. All right, let's get started on that. Version. So now I have to pass in version here. Version 1. Everyone is going to start out at version 1. Version 1. Version 1. Version 1. There we go. All right. So now, how would this work? So this file is like a generic document, as it says, a document generic. So this is sort of every document type implements or has this thing in it. So we have persistent data, non-persistent data. Persistent data is data that is persistent to the file system. So that is supposed to be fully like serializable and saved to the file system. Non-persistent data is data that is only like it only lives while the editor is alive, basically. So you open a document, it's gonna have some maybe UI state that's gonna be put in the non-persistent data. Or other things like temporary textures and stuff, but that's also like UI related. So it basically everything is like UI state ends up there. And we also we expose the types here. Let's see. So here's we initialize the persistent data. Every persistent data then is implement in an init function, and it also needs a deinitialize function, which we're calling here. Same for non-persistent data. Serialize. We basically just serialize the persistent data automatically like this with the std JSON stringify, and so it's up to the persistent data implementation to how it's gonna be serialized. And the goal there is to have all the JSON files be. It's not gonna have any like weird quirks that comes from the SIG. Like let's say, for example, array lists have an items. Well, the struct has like .items, so we don't want to have JSON that's producing. If you have a list, it's just going to be an array. We don't want to have it. A list is going to be a structure that has an items field that then is the array, and then a capacity field that has the capacity of it, because capacity doesn't make sense in JSON. So you want to serialize it into proper JSON and not have any of these weird SIG quirks with it. That's the goal there. And then we have deserialize, which is like loading in the JSON file and actually manifesting the the data in Zig here, and here is where we wanna do stuff with the upgrade system. So what we do here is we first open the file with the standard library here, a directory that we get in here which has been opened, and then we create a reader for the file. So it's basically like an interface that can read the file in a streaming sort of way. And we also create a JSON reader that sort of has like JSON's like state for reading JSON basically. And so that you need to pass in here to parse. If you want to use this function, parse from token source, so you're parsing a JSON object from a token source, which is basically a reader that reads a string basically, or yeah, it reads characters. So this part we need to change because we don't really want to read in the entire persistent data because it might be a non-matching version. So what we want to do is we want to make a structure, which I'm gonna put somewhere else, but we're gonna make a structure that is the document version structure, which is gonna have a version field. So all documents are going to have a magic sort of version field, and this version field is going to be it's going to be a U32. Let's should we do document version int? Let's do that. Let's call this like document header, and this is the actual version. There we go. Okay, so first we want to read in the document version header. So header parsed, I guess we can. So we want to parse the document version header. Now, I'm not sure if we need to have a reader that the reader is this a JSON reader? Yeah, that's a can you reset that? Or do you have to create a new reader or something? Like, if we already used it, do we need to use it again or something? And also the original reader. I think we probably want to like create. Well, we probably want to put this in its own function actually. So let's do that. Let's do like handle upgrade document. And this would be. Let's put this up here. And I think I'm just thinking about how to actually do this. Handle upgrade document. We do need a file. Alright. So we're creating the file. reader. And then we're parsing the header for the document. Right. If there's an error reading the header, how do we handle the error here? We're showing the error like this. So what I'm thinking here is we want to switch on the error because we want to figure out if it's unknown field or I don't know. No, if it didn't find the field. What's all this? Parse error. Missing field, yeah. If it's a missing field, we want to do something. So we want to upgrade at this point from, I guess, version null or something. So I guess we can call like upgrade document from version null, something like that. But and then we return. If it's another error, then it's an actual error, so we'll just return that. Do a try there. And I guess we can do this part. See if we can do JSON error. Let's just do like any type. We also need error. Any error. What else do we need? Upgrade document. Conversion. Nullable with the conversion. Header post. Okay. So yeah, so that's right. So now we load it in. If something goes wrong, we check if it's a missing field. That means it's like an old version. So we upgrade from the unknown old version. Then we return. Otherwise, there's another error reading the thing. So we return the error there. In case of it actually succeeding, we want to check if the version, if the value of the version is less than the config version, Then we do upgrade document from this version. Okay. Nice. Now, how do we want to do the upgrade? So, actually, you know what? We probably want to read in the whole file in that case into the memory instead of using a reader like this, because we want to upgrade the thing in memory. So we'll just read in file contents here. Read all. Let's do read alloc max bytes. I don't know. A gigabyte? No, this is a megabyte. Kilobyte times 1000 is a megabyte. That's right. It should probably not be larger than a gigabyte. Is that the max? Sure, why not? Contents. Yeah, so I think instead of doing this, we do this. And it's gonna probably what we'll do is, I think we'll do var file contents. Then we set a we do this. We send in the pointer to this, because then we can modify the slice to include something else here. Or if we want to upgrade it, we can modify the contents of the slice here and reallocate to a new slice. So this would actually be file contents. Which is not a const, it's this, but it's also a pointer. Okay. I'm pretty sure, yeah. And we don't need to do any of this. So what we do is we parse from slice now instead. And the upgrade document, we actually pass in the contents. So it also can, if it needs to, update the contents itself. All right. Okay. So now we actually implemented a check here already. So we're checking, we're reading the document version. If it doesn't exist, we upgrade it from unknown version here. If it does exist, then we check if the version is less than the config version. If it is, then we upgrade from that old version. Okay. Now, so this is now like it's setting motion here. Down here we actually don't need to do a reader. We do parse from slice. Hang on. We need an allocator, we need actual slice now instead of the reader. This can be file contents like this. And then there's options there. Ignore unknown fields is true. Okay. Reader. Yeah, so the reader, so this is gonna be file contents. Now, yeah, so now we don't actually have access to the cursor. How do we do this? So now we can actually show the error here properly. I mean, I guess we could have like a buffer reader. Is that a thing? Reader. Buffered reader. No, it's just a buffered reader. Bit reader. Counting reader. Limited reader. Where would that exist? Okay, I'm gonna see if I can find it in the standard library. Oh, now the food is here. Dairy. get this set up here. To get a spoon. All right. Alright, so what did I want to do? I want to... Wait, what the hell did I want to do? Oh yeah, like a buffer reader, like reading from a buffer. So let's search for reader. Find... Fixed buffer reader. I mean, why does it have to be like debug? Wait, fixed buffer reader. Debug builds. Right, so you set the buffer and it's gonna read from that buffer, I'm assuming. Reader buffer. Okay, yeah, I don't know. Let's just do fixed buffer reader, I guess. There's no init, so I think we just do this. Buff is gonna be file contents. Do I have to set the endian myself? Where is it? How do I get the endian? Built-in endian. Okay, is this something that doesn't really exist in Zig then? Like a just reader from a string in memory? This is the only thing I find. But then you have to set the endian yourself. Okay. Zig get current endian. Where do I get the endian? Native endian. Oh, it's just standard mem native endian. Okay. Wait, it's not. Okay, so I think it's standard built-in. CPU. Wait. No? Was this changed in... Okay, this doesn't work. Or built in. Ah, there we go. There we go. There's the thing, I think. Okay. This is the same function that's being used in like when it wants to know the native endian. So I think that would work. It's a really weird that I have to do that myself, but okay. So yeah, let's but yeah, maybe there's a reason, I don't know. But anyway, now we need to say reader. So let's create this reader here, and we'll actually now pass this from token source with this reader here. Let's do the same thing here actually, because I want to be able to report the errors that we get. Token source. Yeah, like here, I want to return the error, but I also want to report JSON error. Yeah. All right, and then here, basically. There we go. All right. Just preparing my food here. There we go. Yeah, sorry about the noise. I just need to get something to get me going a little bit here, or to keep me going. Oh. Okay. Now we should get the proper JSON report error. That's what I wanted. I wanted to be able to see the reader here. Actually, that has to be a JSON reader. I just realized. Yeah, it needs to be a JSON reader. Let's do this like make JSON reader from contents. What the hell is this? Default buffer size. All right. JSON reader. Yeah, we'll just return this. And we make you. Okay. All right. I think this needs to be mutable. Okay. Yeah. And we do the same thing here. Wait. Whoops. There we go. Yeah, and defer. Okay. It's weird how this takes an allocator, but then it's... I guess maybe it's like storing the allocator to use it later. But okay, so... Now what? Right, so we're creating our readers, we're parsing them or sending them into the parse function. We're reporting an error if there's an error. Here we're upgrading the document. We're handling the upgrade document, so we're creating the reader, initializing it, we're parsing token source, ignoring unknown fields. We only parse the document version header, and we check if the version field is missing. Then we do an upgrade on the document with unknown version. Otherwise we got another error, so we report that error and we return. If we have an error, or I mean if we have a version, we check if it's less than the current version. If it is, then we do upgrade on that from that version. So right, so we have all the setup needed basically for now this function, and I'm thinking what this function is gonna do is basically like, it's basically gonna be something like this: for from version so first we check first we check if it's null. If it's null, then we do like an upgrade from null. That's gonna be like a special case. So that's gonna be, I think the persistent data has to have that, or either we implement it directly in persistent data, it doesn't really matter, or we can pass in like an upgrade handler struct that will do it for us. Like document version upgrader, and this is gonna be the it's gonna take in the persistent data as, wait, but this doesn't work. This is basically higher level type things. So I do want a type that is have this constraint that it's a document version upgrader. And so we're gonna check here then. This is something that we could do, or we could just put it directly in persistent data. So we could say persistent data upgrade from upgrade document and I guess we put in the original version, which is null. And we supply the slice. Then we loop through. We could also handle a lot of things here. Maybe that's gonna be common. We'll see what's gonna be common for each thing. But we'll do this, and then once we've done that, we wanna do from. That's if the version is null, though. We're gonna assume, though. No, we'll do this instead. We're gonna assume that the version, the first version, first document version, is gonna be equal to 0. Well, that's the yeah, that's the first version. That's 0. Okay. So if so, this is not null now. First document version. Okay. So now if this, so now this is gonna be from version to config version. So actually, let's just set this to usize. This makes it a lot easier to do this. So v for version. And then we just do upgrade, because we just need to pass in the current upgrade, because now this will basically be, okay, you're upgrading from version 0, then we know that it's gonna be upgraded to version 1. And then from version 1 to version 2, version 2 to version 3, and so on. So we just need to put in the from version here, and then we know that the next version is gonna be the version after that. So we don't have a case for this. So this is basically gonna be the thing. Alright. So now this basically forces all of the persistent data to have upgrade document functions. So here you can see, well, okay, we got some other errors here. Right, expected. Okay. Okay, there were no errors, but this should force the thing to have I'm not sure why I don't get any errors. Okay, now we get errors here. Okay. Right. So this part, this needs to be a var, I think. Yeah. Document version has no member named next error. What? No field member named read. Okay. Right, you don't have read? Why? What? Okay. Oh. Wait. Oh. Okay, okay. I found it. I found it. Here. So apparently here we're in standard IO. I think it's IO with, yeah, IO reader. And then I scroll down and because I was trying to find, like, maybe I could use this, I thought, and create my own thing. But then because it's weird that there's no like buffer reader or whatever. But then I scrolled down and I saw this fixed buffer returns a reader, constructs a reader such that it will read from buffer and then end, which is exactly what I want to have. So this function actually returns what I want to have. Okay. So we don't need to worry about this fixed buffer reader. What we want to have is, well, it's gonna be IO reader. I don't know, any reader, generic reader. Let's just do any reader, I guess. And then this would be reader dot fixed wait, how do you call this? Wait, which one is this? I don't have this type. Maybe it's for the new version. Okay, and apparently this doesn't exist in the one that I'm using here. What about fixed buffer stream? Maybe this? Right. So we could use fixed buffer stream. Okay, so standard I fixed buffer stream. Okay. Fixed buffer stream. And the buffer is this. And then I want to have a reader from that. There we go. Oh, wait. Okay. So this has to live like, okay, this one, it needs a stream to target underneath. And if we do it like this, that doesn't work because the stream will like disappear. Only the reader will remain. Okay. Let's just make. This can create its own reader or stream, I guess. We'll make a thing there. Yeah, we don't really need this function. It's just a mess to work with. This is the file reader. Oh, that's the JSON reader. I guess this would be. Okay, let's do. Well, actually, we need a file stream. Is this, and then the file reader is file stream dot reader, and then we pass in file reader now, and yeah, prefer reader initialize. Okay, now we need to do the same thing over here. So we need a stream, yeah, all this crap. There we go. Except this needs to do what's there. Okay. Do we have these errors still, or? It's expected, found const, okay. Which function is this? Parse from token source. Oh, so this needs to be var. Right. I'm not sure what this error is. Why do we get... Oh, because the source... Okay, so what is the source? Is it the reader? The JSON reader? The JSON reader? Where do we have that thing? Invalid format. Okay, let's get the full diagnostics here. Too few arguments. Where is that? This one? Oh, yeah. Path. Now this conversion. Oh, here. Okay. So this would be, I guess, type of reader. Wait. Yeah. What's this now? Oh yeah, now we get these errors. Okay. Okay, so we fixed everything else. Now we get a whole bunch of these errors. So this is basically forcing us, it's basically like an interface almost, you know, you could almost compare it to an interface. So it's like a forced, we force these things because we're trying to call the function, but it doesn't exist here. So now it complains that all these structs do not have this function. Sorry about the noise there. Okay, so I guess next thing is just start to implement these things. So I think everything should be like, you know, it doesn't really have an upgrade from, like, let's say, well, we need to have a function for it at least in everything, but only time app would actually have some sort of implementation right now. So we'll go over here, and I guess we could add it after JSON maybe. So, or maybe before actually. So this would be upgrade document from version, final contents, right? And I guess this could technically return errors like let's to try these. There we go. Right, we need document version, except it's in here, I think. There we go. Right, so for this is gonna be an empty thing, I think, because we don't really have a next version for this. This is basically gonna be the first version, but maybe we'll have like a special case for the first version is gonna be like upgraded to a, so the 0 version is gonna be upgraded to the 1 version. Actually, it does make sense. If the first version, if this is like 0, then it doesn't make sense because we don't have that version yet. So we don't have version 1 yet. So we could probably assert, we're asserting that from version is less than, or yeah, it's gonna be less than, because we're not gonna get in here if it's the current version. So I will say we have a version. Yeah, we also need this, we also need to store this version. And we also have current version is 1. So if from version, we're asserting that from version is less than current version. Right. And then now we don't actually do anything with this because it's not, yeah, we don't have a different version. Actually, current version is 0. Okay. And let's go Okay, so let's copy this stuff to the other documents. So yeah, time map data. So document time map persistent. It's basically exactly the same thing. Animation. Whoops. Now the texture document as well. Alright, that's it. Okay. There's a lot of food there. Okay. Okay. Oops. Okay. So. All right. Upgrade document. Right, so now we need to go to our there. Actually, the config does not have now the version here. So I think we actually remove this, and what we do is we go to our we use the persistent data to get the current version. So now we're gonna get some errors. No. Persistent data dot current version. Okay. There we go. No field name version. Right, so now we remove this again. Oops. Okay. Now we go to the tile map. Persistent data, and this is actually going to be first plus 1. Is that good? It's going to be bad if someone goes in and change. I mean, it's only me working, but if you change this, that's going to be bad. Don't change this. I don't know. It feels self-explanatory. But it's good to have a reminder. Okay, anyway, so yeah. This now has a version bump, which means we have to implement the version here. Maybe there's a better way to structure this to actually make sure that, okay, you have like a list of version, like list. Maybe you have like a list of versions instead, something like that. Like let's say you have like a upgraders, and then this is like a list of, I guess, a comp time list of functions that, or just a document upgrader with time up data as a thing, and then and then this would be, like this. So then for each document upgrader you put in here, that's another version. So I think that would be a more robust version of doing what I'm doing here, but this will work, I guess. Yeah, this will work for now, because now we have to like sort of hand wavy, or sort of, figure it out here that let's say if from, maybe we should even use a switch, I don't know, switch from version. If it's the first version, then we do something else unreachable. So if it's the first version, then you do an upgrade here. So here's basically the same list that I was thinking about that we're gonna implement, except we do it as a switch instead. But I really think I think the other approach is probably more like robust. And the reason for that is basically you don't have to deal with this, just this integer. You basically define the list instead. I don't know. Maybe, I don't know. Let's just do it like this for now, and we'll see. It's easily changed later though. It's just the code that handles the upgrades and how it does it. It can be changed later into something else. The important part is having the upgrade system, or any upgrade system. Okay, so the first version, so yeah, so this upgrade, we could have a little side note here that explains what we need to do. So old version had tiles in a flat array. Now it's a 2D array, two-dimensional array. So that's the difference. So the question is, how do we actually do this now? Do we need to store the old version as a struct that we can load in? Because we need to read in the JSON. I mean, maybe we can create a struct that is basically the thing we need to update it. How would that work though? Basically, it would be nice if we had like a surgical JSON thing that you can you can go in and sort of like JQ, the terminal tool, JQ, where you can just go in and, for example, you can just delete. You can go into an object and just delete one of the keys, or you can change it to something else depending on other things in the document as well. So you can do basically everything you can think of in that tool. It would be nice if we had the same thing here. You can like surgically go into the string while reading it as a JSON. Basically JQ in a programmatic Zig library. Maybe JQ actually has a library somewhere. That could be cool to check. JQ as a library. So where is it? It's in C, so it should be. binaries. I wonder how if you can actually use Zig to easily use this as a library. What did I say here? So, oh, building from get omni auto reconf. I don't know what that is. It's probably some C stuff here. Configure with. Okay. J8. Oh. Archive, read only, okay. There's a fork. I mean, it's probably good enough, right? Why is it like archived? To do. So does it work? So here's some data file, and here we include some stuff. Okay. Initialize. Okay. Tear down. So data equals JV parse. So the string. Wait. So what is this? Okay, so I'm assuming it's like some sort of data thing from JQ. JV is like, I don't know. JV string value, JV load file. So is it just like the descriptor to open the file or something? And then input state JQ user. Input free. Set input callback. Next input call, okay. Input state. Input in, okay. Okay, here's the actual JQ expression. Cool. And then it's compiled, okay. Great. Oh, you need to duplicate it. Because it's freeing it maybe. And then it's checking for errors there. So is this just a compile? Like this is just a result if it's compiled or not. Here you start. JQ. What is JQ? Oh, it's okay. With the data, okay, 0. So you basically, this seems like it modifies the sort of JQ instance to use this. It's like setting it here, okay, and then you do start, and then you can wait for the result here, I guess. So it's not super straightforward, but you could, I mean, you could write a wrapper around all this logic. So it is possible. The question is, do I want to import this to use it? It is pretty cool, actually, what you can do with this. And also we could use this to actually grab out headers. Instead of using the standard JSON library, we could use this to grab out headers, because I believe this should probably do it a lot better. Like, it doesn't need to read in the entire file and stuff like that. We can actually try that. I have JQ here, so what if we make a new file and we have, like, let's say we have like version at the top and then ID, and then we have a bunch of crap in here. And then what if we don't have, like, it's like invalid JSON? Then we do this, and we say just stop version unfinished. Okay, so it does check for, it does check the entire thing. I wonder if you have like a lot of things in here. Oh, this. No, it's still reading the entire thing. Okay. I wonder if that's like a flag that you can have or something. That it doesn't need to check the whole file. I don't know why I'm obsessed with this. It's just, it probably isn't that big of a deal. Right. So back to where we were before. Where was that? Document time app. Because the issue here is, like, now we have to keep, we could, what we could do is just have a, we could just have this as like the old version. So document 0 first, I guess. Let's just call it 0. So this is, let's make this a struct, and this is the actual struct. But we don't really need to do anything with version, ID, or history. Well, version we do actually need to do, but really we just wanna read in the time map and change it. Or maybe actually upgrade document. Maybe maybe it makes more sense if we just upgrade it in memory. Like, we're reading the old version and then we upgrade it in the memory instead. Yeah, I think that makes a lot more sense. Probably. because now if we have just this string that we're gonna pass around, then we have to like serialize, or we have to deserialize the first version, then serialize it into the next version, then deserialize that again into the next version. I have to do that each time instead of just deserializing it first with the correct version and then upgrading it in memory to the correct version and then returning that as a result. Like you could even have, like in a document upgrader, you could have, well, this would be a function that takes okay, I forgot what I was doing with that. Never mind. So anyway, so you could have this, and then you just read that in. But yeah, because what I'm thinking is, okay, do we even want to put, like, have file contents here then? And then we should return like the actual persistent data as it is now. So we should just return self here. Yeah, because what I was thinking is, what if we change the input as well? So if we change the input, but that's gonna be a huge issue. Unless we make this thing a generic. Because what I was thinking is that this is the parsed first version that we get in, and then we upgrade it to the next one. That was my idea first, but we can just as well do it here, because we could sort of automate that portion of upgrade. But I'm not gonna think too much about it. I'm just gonna do it like it's like I want to do it the easiest way first, but it's also good to know to think about not painting yourself into a corner. That's usually how I'm doing these things. So that's why I'm thinking a little bit ahead as well. I like to think ahead so that I don't see, oh, but if we do it like this, then we're gonna have a lot of trouble later if we want to change this or something like that. I don't think it's the case here. I think we can just put file contents in here. We are going to read, like define each document as a struct here. That's not a big thing. And then we can parse it as a JSON with that there. And I think I want to move this function to, I don't know, some sort of JSON. Oops. There we go. So now we can access it here as well. Or here rather. And what else do we want to do? Let's add a convenience, maybe. I want to basically put this into convenience, this part. Yeah. Parse from slice from, yeah, with arrow recording, something like this. But I do also want to catch yeah, the thing is, I don't want, it's sometimes it's not an error, like sometimes. So let's not do error reporting. But then we don't have access to the underlying stuff. Because the thing is, in here, this thing is not actually an error. Okay, I guess we just have to deal with it. So this would be parse options. So we need an allocator. We need the buffer. And we also need the type. And then the return type is parsed t. Right. Now, yeah, we don't catch the error here. There we go. Or do we catch the error actually? Yes, we do catch the error, and we report. And okay. Alright, let's go. So here we can't really use it, but I do want to use it up here. And now it's basically going to be a try, and then we don't need to do any of this. There we go. Right. So let's do document 0 allocator buffer is, yeah, that's fine. Contents. Parse options is nothing. Okay, so we'll get the parsed value out. We will do a try. Okay. I suspect this is gonna look the same for each of these upgraders, but we're gonna have to see whenever we have to implement a new one, and then maybe we'll revamp this version a little bit. So parsed. Right, so now we have the parsed. Maybe we'll actually just return the parsed version. No, we have to handle the parsed version here. Oh man, but that means we have to implement the clone function. Do we really need to do that though? No, I think we just need to convert. We need to have a special conversion logic that turns this into the next version. And I think this works really well actually, because then we can have a label here, upgrade, and what you could do is, no, but then you need, okay, I think we need a couple. I think we need another thing here. We need a upgrade document that is gonna take, oh man, I think we actually need to do the upgrader struct. Because the thing here that we need an upgrade function. Now this upgrader already knows which version is gonna upgrade from. So and the thing that we're gonna get in is the actual parsed document. So let's say this is document 0. Let's move this out. Yeah. Oh man, but then okay, yeah, we need a 0 version of the tile map. Oh man. We need to keep this old version. Basically everything is the same except for the Is this really how we have to do it? Anything? The other stuff is not subject to change. Maybe it's time to implement testing as well. Have some tests. I mean, if we have tests, then we don't really need to copy a lot of stuff like this, like the grid and stuff, for example. So that means if you change the grid, then okay, nice, now you can. But maybe it's better to copy it actually. But like the vector, if you change the vector, that's not possible. This has to be the same thing. And this also is going to be the same thing, I think. What about tile? That's also a thing. This, and we need, of course, the tile source. History. Wow. Should we just skip the history? Because it doesn't work at this point anyway. I just skipped the history. Okay, so it's a little bit more involved if we want to do it like this. But I guess it's not impossible, you know. What we also could do is we could make a directory on persistent data. No. And then here we have like upgrades. And we'll do we could like put it here. Right. And we also need JSON, right? Or maybe not in this, but we do need JSON. We do need. Actually, we could just change these into slices. We don't need to. We don't need that as a pointer. Name doesn't make sense. Yeah, let's just do this because we're not gonna modify this version. Okay. All right. Then I think could have a function here. How do we want to do this? Okay. So if we put this in an array where the first is 0, this is 0, we know now we can have the struct to upgrade it. So this would, let's not call this document, let's call this just document. Okay, so we know we have a struct called document, which is the actual like JSON structure. Then we also have an upgrade function. So that means that we can automatically parse for that document. So if we go back here, we'll see, okay. I'll move this comment up here. Version, I mean, it actually does not have a version, so we'll remove that. So basically, to get the upgrader, we will have a, let's say we have a list of upgraders. We simply do this to get the upgrader. Right, and that can be automated from outside. We don't really need to implement this in everything. We have a thing called upgraders, which is going to be a comp time list of well, basically document upgraders. Okay, and a document upgrader has a document well, it's gonna be types, isn't it? It's gonna be types here. So this would be upgrades 0, right? So that's version 0, and then every time you add a new one, you have to add it here. And this could technically also be like automated, like magic, where in comp time you read the upgraders from the directory. I think so anyway, that you can read all the sig files in there and then generate this import from that. I'm not actually sure if you can do that, but you can do it like through the build system. I know that, like generate code that you import So it could be fully automated, but I'm not sure if you could do it through comp time. Is what I'm saying here. Okay, so that doesn't need to be. Okay, so right, so that's the upgraders. So here we get the upgrader from this list, and then we know what we know the upgrader what it has, but SIG doesn't handle, like it can't set it to like an interface type or something like that. Even though probably could, like if we had, yeah, if we had like the way they do it with allocators. I mean, I guess you could do. No. Well, yeah. I mean, let's say you have, just like allocator, you have document upgrader and then a v table, which is a pointer to any opaque, I think. Or and then you have the functions that you want to use. So you have pubconst document is a type, but then it's set to undefined, I guess. Is that even possible? No, that's no. So what you have to do is if you have to have a function. That's right. Get document type. I guess you can say, I guess you can do this, document. Return vtable. How do they do it in? Oh, they have a vtable like this. So the pointer is the underlying data. vtable is the implementation thing, and then the functions will call the vtable here. Yeah. With the pointer. So each function needs to handle the conversion of the any opaque. This would be the v table, and then struct. Wait, v table is a struct that has document. No, wait, how did it work? Oh, it's functions like that. Okay, so it's like this is a pointer to a function, and first thing it takes is the underlying value, except it doesn't because we don't have one. So yeah, that just takes that and returns a type. And then we have upgrade that returns, I mean it returns the next version. So each upgrade needs to refer to the next version as well. Oh dear. And then the next version, whoa, okay. And after all that, we need to have a final step where we basically take the latest version in this sort of mangled JSON form and turns it into the current version. Which, I mean, technically it should just be a matter of serializing and deserializing it again, I guess. So that's actually not that big of a deal. But structurally here, the problem that I'm facing is like, okay, we have an upgrade 0. Okay, it upgrades from 0 to 1. But we need a type for document 1 as well in that case. So basically, we need... Actually, this should be... So we need 2 functions in that case. Wait, how did that work? A allocator? Oh, that's self. Okay. Alright, so we need self. Yeah, so this is how you would implement the thing. Okay. But this is like document previous and document next. Let's say we have previous and next. So we always need these 2 things. So okay, so what I'm thinking is we change this structure a little bit. Now the previous is a document. This is gonna be that, and next. Can you do this? Wait, no, that's what you return. You return that. I mean, it's all com time, so it should be possible, I guess. I probably need an allocator as well, maybe. Okay, and then the v table here is like we get the previous documents. Oh man, how would this work? I think we have to have a comp time. We have to have like make this into a generic. Because how will this work? No, the v table is generic. Okay. I think the problem is it's very hard to define the type of this. Maybe. Well, how, like... Do we need to like comp time switch on this or something? Because we could do this if we don't define a type. Okay. Then if we say, for example, upgrader 0 is this, then upgrader 0, we know what document is, for example. Except, well, let's forget about that for a second. Right, what is this? Yeah. Document 0. So this would be this. Right? Could we do like comp time if this is equal to import wait, what do you mean unused switch label? Oh. Well, let's just do this then. Oops. Okay. Yes. So let's do yes and no. See, do so we don't get both. No. Okay. So it is the same. Cool. Well, it makes sense now that I see it. Okay, so this means that, you know, we can define this. This basically comp time. It knows everything. This basically becomes the list that I was talking about. That you have this list of upgraders, and but the issue now is if we want to do something like this, we need a little bit more structure. I think if it's even possible. Well, it should be possible, you know, but it's gonna be more like you don't really need a V table here. What we want to do is, whoops, we don't do the V table stuff. What we have is that this is a function that takes previous and next as a type, and then we return a type. Whoops. Okay. And then well, I guess we also need a function that is the actual upgrade function. So could we just do this like upgrader? So the first one is, let's do an allocator, and then we get previous and it returns next. Should also be comp time. And then here we have function upgrade. Okay, something like that, maybe. Function type cannot have an inferred error set. Can you do this? Okay. Yeah, I'm just trying to figure out how to structure this. So I think what we want to do is we want to have the versions. Okay, we put the versions like that. And then the upgrades. And then we need version 1. Okay, so we keep the versions in one place. And then the upgraders. Something like this. Okay. But then do we need this monstrosity here? I was thinking to have this to sort of generalize and be able to automate stuff here. Okay, this we know this works now. So actually what we could do is we could switch, we could do inline. I think it's like first to current. Something like, I think it's, you could do something like this to get that out, maybe. Okay, I have to look this up. How will you do this? Because I'm pretty sure you can like have a comp time known thing there. So let's do zig switch. Wait, here. Yeah, I think this is comp time. Yeah, comp time known value. So if you have inline and then something here, but I'm pretty sure you can have a range too. Yeah, inline can combine with ranges. So you have 0, 3 dots, and then something else. You get this index which is comp time known. Which is pretty cool. So you could do this, which would basically generate a bunch of if it's 0, if it's 1, if it's 2, etc. And then we do we get the upgrader. So now that should be like a comp time known thing. Wait, this should be... Yeah, we can make it, yeah, we can do this. Let's also like generalize that so we don't have to redo that every time. I mean, I guess we could use this. We could put this somewhere and use that. Like if we, like, let's say we put it here for now. And we simply do like username. Something like this. Yeah, you could do that if you want. I'll just, I don't know. I don't know if I'll keep. I think I'll just remove this. Okay. And yes. So yeah, so we parse the document. Now this is going to be the document prev there. Now what's good about this, if you go ahead and implement this, oops, this upgrader, and you put it in the list over somewhere here, this list here, actually this should be one like this. Wait, one is outside. Oh, wait, is it inclusive? Are ranges inclusive? I guess so, because they do like -1 here. So you do -1. But there you could see, like, that was a, let's say we bump the version, all of a sudden you get an error because this is not updated. So you have to make the next thing if we bump the version. It's all like in the, it's all comp time, it's all like guarded, so to speak, by the compiler, which is very, very nice. So if you just bump the version, you're gonna have to implement upgrader as well. I guess what's not really tested is, well, what you could do to actually automate a version check, a version break check, would be to serialize, like make a new document of the current version, serialize it, and then deserialize it using the latest upgrader. Like you take the latest upgrader, upgraders like this. Wait, why do you not have? Oh, it doesn't have a length. I thought it was like a slice, or maybe not. Then it's like a weird tuple thing. What about this? Oh, it's like a pointer to a tuple. Wait, would this even work now? It doesn't complain about have to go here soon. Let's see. But it's a very interesting problem here. Really nice to tackle this. I mean, I've sort of tried to tackle this issue, like upgrading documents in other languages, but this is Zig really has a way of making a really robust. You can make a really robust, like, type-wise system here, which I really like. The only thing I don't like about this is that we have to keep doing these weird like the versions, like these ones. We have to like keep this old, but this is basically only type information. But it's a little bit, I don't know. Maybe there's a better way of doing it. Maybe not. I don't know. Maybe, you know, one thing that you could sort of do is only specify what has actually been changed. That could be like a comp time thing. I don't know. It feels very overkill. But yeah. Okay. The idea here is that let's see. Let's apply pixel. Let's just see what errors we get here. Okay, we don't get any errors. So wouldn't this be a comp time value? Does lane actually exist? I guess it does. Let's log it and see. Do we get a... Well, we have to run. So what would it be? 2? Okay, so it does exist. Okay, so this tuple actually has a length. We don't need to make it a slice. Okay, that's good to know. So what we could do to do like an automatic break and change check for loading the JSON file is we take the latest upgrader, then we basically serialize, we create a new document of the current version. We serialize it, then we take the latest updater. Why am I typing like that? Take the latest upgrader and not upgrade, but take the latest upgrader and take the next version of that. Now deserialize using that next version. If there are any JSON errors, that indicates a breaking change. If not, it's probably fine. So that's how you could implement automatic breaking change checker. So you don't have to like reason every time, and maybe you miss something or you don't really think about it, and then all of a sudden, oh man, we can't, like, well, the editor crashes. Why? And then you have to go on a hunt for it. Here we could even produce a log that says exactly what's the issue. Like for example, you could let's say we produce a structural analysis of the JSON format, and then like the serialized JSON format, and then we take, so then you have a normalized sort of analytic report of that thing, and then you compare that to the next version. Yeah, so you could do it like that. But okay, I'm basically dreaming right now about these things. So yeah, I'll just put this somewhere, so I guess it exists. All right. Anyway, now let's say we have this parsed thing, and what do we want to do? So yeah, I think at this point we don't want it to be a parsed thing. I don't think. Man. Yeah, this is... Wait. Couldn't we just create an arena allocator? Like at the top level here. And use that to parse this JSON stuff. Because we parse it, we send it into, no, we send it into the upgrader. The upgrader's job should be to basically clone the whole thing. Is that true? Is that too much to do? It feels unnecessary. It feels like you should only like upgrade the thing that actually needs to be upgraded. The rest could be the same, and then the upgrader has to handle what needs to be deallocated. That feels way more efficient. So what does that mean here? I think that means we can't really use... We could make a version of this that is leaky, I guess. And we just call leaky here. Whatever, I'm not gonna do two different versions right now. Okay, let's do the leaky. So this is next, or this is previous. Okay. Now we can call upgrader.upgrade on that, so we need the allocator as well. Now we should get the next out. Now comes the problem here, because what I was thinking, if we have this as a label on from version, it would be nice if we could just call now break upgrade and then v+1, because then we go to the next upgrade. Okay, and then we have like, if we get to current version, then we're done. So we just return, But now the issue is that we need sort of like a pointer to any opaque that we return. So it's like current is an any opaque. Okay, so here we set current to this. And I'm gonna, but the problem now is like if we already have current, then we don't really need to actually, couldn't we do this? Could we do this? Okay. Yeah, that should now become the one of those things. Maybe we do, I don't know really, what would the type be? This doesn't really make sense. I guess it's one of these. I don't know if that's possible. And then what else? Alright, let's just try and get a little bit further, and I have to go. So, let's see. Previous. Yeah, so I'm not sure if this actually works, but because previous is like, we don't know really what type it is. Then, once we have that, we have a new switch from version. And we do inline this again, else unreachable. But now, actually this needs to be like an opaque here. There we go. So then we say prev with type prev, and then it's like a pointer cast. The type is gonna be a pointer to, well, we're gonna get the upgrader, and it's gonna be a pointer to upgrader dot document previous. So that is what is gonna be there. And then we do upgrader dot upgrade we'll do, wait, this is shouldn't be const, this is a variable, yeah, because this is gonna change. Let's do like current. Okay. So current, let's call this pre actually, and then we actually, now we break no, we set current here. Current equals I think we need to allocate this. We need to do a create upgrader document next. I guess we can try. Here it's fine, because we're sort of, well, actually no, it's not fine. We can't just put a thing here. No, so we need to do, no, but this, oh man. No, so we can't just turn this, we can't just do this. What we have to do is we have to create, we have to allocate here, so we have to do previous equals allocator create, and this is upgrader document previous. Oops. Okay. And then this is populated with this, and then we break with the pointer. So now this is set to a newly created pointer there. Okay. That's the first version. Here, we're pointer casting it there. We are creating the next one. We send previous into the upgrader, and we're populating next with that. Now at this point we can remove, we can destroy the current one, and at the end we set current to be next. So each step we are grabbing the upgrader we need. We're converting current into the previous, so that's the previous version. Then we are allocating for a next version here. We're upgrading, so we're populating next with the upgrade. Now we're destroying current. So that's the previous, because we don't need it anymore because we have the next version. And then we update the current to point to next, right? And at the end we do a break upgrade v plus 1. Okay, and we put a label here. Oops. And so this basically says that, okay, now you've done this upgrade, now let's do the next upgrade. So when you do break like this with a label in SIG version 0.14, you have a label switch. It does the switch again, but with the new value that you provide. So it's gonna be, the first iteration is gonna be from version +1 now. And you get up to current version, but once you're in here and you're not at the current version anymore, actually we want to have current version. This is the terminator. So if you get up to the current version, then we return pointer cast current. So then it's like you're gonna get a pointer to, well actually we could just return the actual thing. We pointer cast, okay, so what we can do here is we can say var, so let's copy it first, final version, or yeah. Let's do pointer cast this is gonna be like upgraders, actually upgraders current version -1, right? And then document next, that's the final version. And so we want to pointer cast this as a pointer to a document final, and then take the content of that. Right. So we'll cast this as a pointer to a document final. We take the content out, so we basically copy the content into this part, and then we can return that. But before we do that, we actually destroy current as well. So now we've cleaned up after ourselves, and we return the final result as a value. And if and this is basic, this is actually generic for all upgraders at this point. There's nothing here that is specific to time maps. It's gonna be the content itself that is gonna be, the only thing that is specific is this list here. So if we force all the persistent data to have those lists, we can just move this function into the generic. Yeah. So we move it into generic. Also, we don't need to loop here. Yeah, let's just remove this function, but it's good. Basically the same thing. Oh yeah, and current version. We don't have current version. But that's gonna be persistent data dot current version. Yeah. And this is persistent data of upgraders. All right. But that's gonna be it for this time. So probably gonna continue with this as well next time. So thank you very much for watching, and